Hi, so this video is more about the process of differentiation and practice in it and some of the key features that you're going to encounter during differentiation. So we've looked at this one already, which was the differential of x squared. We brought the power down and put the 2 in front. We took one off the power to get 2x to the 1, which is equivalent to 2x. Now, I'll give you a moment to pause the video if you want to try these yourself. We've got x to the power of 7 here, and we've got x to the power of minus 3 here. So if you just want to try those yourself, give the video a pause right now, and I'll go through the answers very shortly. Okay, so this one here, if I differentiate, I should get 7x, to brought the 7 down, to the power of 6, and this one, we bring down the power of minus 3, multiply by that, and then subtract 1 from the power. Something to be careful of is because we're already in the negative numbers, we're going to go further into the negative numbers when we take away 1. So we're going to have a power of minus 4 there. Hopefully you got those. Now, let's have a look at some of the key features of differentiation. Okay. So the first one we want to talk about is multiplying by constants. So basically, if you have a number in front already, what happens? And what happens is, when we bring down the power, in this case when you bring down the 4, you just multiply it by the number that's already there, which in this case is 3. So for this example, I'd get 4 times 3, which is 12, and I'd still take 1 off the power to get 12x cubed. Now, once again, I'd recommend you try the remaining 2 in this row. Pause the video here, and when you're ready, unpause it and I'll go through the other 2. Okay, let's have a look. So this one, bring the power of minus 2 down, multiply it by the 5. Minus 2 times 5 is minus 10. Take 1 off the power. Minus 2 take away 1 is minus 3. And that's our derivative. The next one, some of the students had an issue with this power here. What I recommend is you could call it 1.5 if you want to do. Convert it to a decimal, that might make it seem easier. Now, if we do that, 1.5 times 10 is 15. Take 1 off the power. If you're thinking about it as a decimal, you're taking away 1 from that. You're going to get a half. You can either keep that as a decimal, or you can keep it, or you can write it as a fraction. I'm going to write it as a fraction. I like fractions. Nice. Okay, the next situation that we want to have a look at is cases where you have more than one term, like these along here. So all you do is you just differentiate each term individually. Right? They don't interact in any other way. So if we were dealing with this one here, you'd bring the 3 down. 3 times 2 is 6x to the power of 2. Now, we have to be a little bit careful with this one. There is technically a power here. We haven't written it explicitly, but it is technically a power of 1. So if I want to differentiate 7x to the power of 1, I'll just use the powers rule. I'll bring it down. 7 times 1 is 7. Take 1 off the power, 1 take away 1 is 0, and I get 7x to the 0. And this is correct, but there's a little bit more I can do with this. What you may remember from rules of powers is anything to the power of 0 is equivalent to 1. So therefore, I could write this as 6x squared plus 7 times 1. And then 7 times 1 is just 7, so then the times 1 is kind of unnecessary too. So let's get rid of it. And that's even better again. Tick and a smiley face. That's when you know you nailed it. Okay, pause the video again. Try those other 2 and unpause when you're ready to give them a little check over. Okay, let's see. So I'm going to get 4x cubed from the first term. I'm going to get 3x squared from the second term. And I'm going to get 2x to the 1 from the last term. And once again, the x to the 1, the power is unnecessary, so I can get rid of it if I want to. For the last one, multiply the 8 by the 5 to get 40. Take 1 off the power to get x to the 7. Here, we're going to have minus 5 interacting with plus 3. Minus 5 times 3 is minus 15. And if I take 1 off the power, I'm going to go further into negatives and get minus 6 out there. Okay, and finally, let's talk about constants and single x terms. Now, we've kind of dealt with one of these already because we dealt with something that had a 7x in it just up here. So you might already expect an answer for 5x. There's a few ways of thinking about it. You could either call it y is 5x to the 1, in which case you would get this. And you'd get your answer there. Alternatively, you could think about it as a straight line. And the straight line y is 5x. If you think about it in terms of mx plus c, you know that 5 is the gradient of that straight line. So you could just jump it there for that same reason. Now here we've got y is 28. If you were to plot that, it would look like this. It would be a completely horizontal line. It would pass through 28 on the y-axis, and the vertical height above the x-axis would always be the same. It would always be 28. So if you were looking at the change of y, well, y doesn't change. Y is always 28. So your gradient, since that relies on the change of y, is going to be 0. There's no change. And finally, we've got this last one here, y equals 3x plus 7. Again, you might have some inkling of what's going to happen based on the previous two. But the line y equals 3x plus 7, something like this. It's got a gradient of 3, and it's got an intercept of 7. So you could just go straight in and say, yeah, my gradient is 3. The 7 is irrelevant because the 7 is the y-intercept. It decides where we cut the y-axis, but it doesn't control how steep the line is. Okay, so those are all the key features, and we should be okay to crack on with the main exercise.